Imagine a group of 10 people having participated in a selection test. In a first round, the people who are having height more than 5 feet will be qualified for the second round. And in the second round, people whose BMI is less than 19 kilogram per meter square are rejected. Here 5 feet and 19 kilogram per meter square are reference points. With the reference points, the results are finalized. Here we can also represent this as a graph for quick understanding. Similarly, solution of linear inequalities in two variables can also be represented graphically. Let's see how it is. To understand this, let us discuss a concept of half plane. Consider a line that divides the Cartesian plane into two parts. Each part is known as a half plane. If a line is vertical, then it will divide the plane in the left and right half planes, and a non-vertical line will divide the plane into lower and upper half planes. Hope this is clear to everyone. Okay, so now if you plot the point in the Cartesian plane, the point will either lie on a line or will lie on either of the half planes, that is right or left, or the upper or the lower plane. Now let us consider a line ax plus by is equal to c, where a is not equal to 0, b not equal to 0. Since inequality is not exactly equal, there exist three possibilities, namely ax plus by is equal to c, ax plus by greater than c, and ax plus by less than c. Now let's visualize these possibilities graphically. And now for the first case, ax plus by is equal to c. For this case, let us assume an equation which is 2x plus y is equal to 4. Here substitute x is equal to 0 in the equation and you get 2x plus y is equal to 4, you get y is equal to 4. Then if we substitute y is equal to 0, we get x is equal to 2. And then if we take x is equal to 1, then we get y is 2. By plotting all these points in the graph, we get a straight line. So you can see we have a line over here. From this, it is clear that all the points xy lying on the line satisfies the given equation, that is ax plus by is equal to c. Or all the points xy satisfying the equation ax plus by is equal to c lies on this particular line. Now next, consider a case ax plus by less than c. Consider the equation 2x plus y less than 4. We have already proved that all the points satisfying the equation ax plus by is equal to c lies on that particular line. So the point must be lying either on the lower half or in the upper half and not on the line here in this case. First, let us assume a point on the upper half plane, that is say 3, 1. So let us take this point as 3, 1. Substituting this in the equation 2x plus y less than 4, we get 2 into 3 plus 1 less than 4 or 7 less than 4. That upper half does not satisfy this particular equation, does it? No. Now let us assume a point from the lower half, say 1, 1. Substituting this equation in 2x plus y less than 4, we get 2 into 1 plus 1 less than 4 or 3 less than 4, which satisfies the lower half of the equation. Understood how we are getting which part of the graph is satisfying? Yes. Now let us assume another point here, that is minus 1, 2. So when you take minus 1, 2, substituting that in the equation, we get 2 into minus 1 plus 2 less than 4, 0 which is less than 4, which satisfies the lower half of the equation. From this, it is very clear that all the points xy satisfying the equation ax plus by less than c lie on the lower half plane. Therefore, the solution region here should be the lower half of this particular plane. Similarly, for case 3, that is ax plus by greater than c, all the points xy satisfying the equation ax plus by greater than c must lie on the upper half plane. Therefore, the solution region is always the upper half region of this particular plane. Now let us focus on how to represent the solution in the graph. First, we should be clear with what is the solution region. The region containing all the solutions of an inequality is called by the name solution region. Simple. In order to identify the half-plane solution region, it is just sufficient to take any point AB and remember that the point should not lie on that line. For our convenience, we can take the point 0, 0. If this point satisfies the equation, we have to shade the solution region which contains that particular point. Here we have shaded our solution region with respect to the straight line. So we have to doubt whether to include or exclude this line in our solution. Now observe carefully. So you can see that if an inequality is of the form ax plus by greater than c or ax plus by less than c, then the points on the line ax plus by equal to c are not to be included in the solution region. It won't be included. Now, so draw a broken or a dotted line in such cases. So that is how you identify the graph when the inequality is either greater than or less than. Now, if the inequality is of the type ax plus by greater than or equal to c or ax plus by less than or equal to c, then the points on the line are also included in the solution region. So draw a dark line in the solution region in those cases. Let us examine through by an example. So here, solve 3x plus 2y greater than 6 graphically. First of all, plot a graph which corresponds to the line 3x plus 2y is equal to 6. For x is equal to 0, the value of y we get is 3, and if I substitute y is equal to 0, I get the value of x as what? 2. As we have seen before that for inequality 3x plus 2y greater than 6, the line should be excluded in the solution region and should be represented by what? A dotted line only. In order to identify the solution region, take a point 0, 0 and substitute in the equation 3x plus 2y greater than 6 and check whether it satisfies the inequality or not. So when I do that, I get 3x plus 2y greater than 6 or 3 into 0 plus 2 into 0 greater than 6 or 0 greater than 6, which is false. So it is not satisfying. So the point 0, 0 is now in the lower half region, as you can see here in this graph. It does not satisfy the given equation. It is also understood that any point on the line also would not satisfy the given equation, as we have a dotted line over here. So the upper half region will be our final solution region, excluding the points on the line. Now, if the question is like this, solve 3x minus 6 greater than or equal to 0 graphically in a two-dimensional plane. First of all, plot a graph which corresponds to the line 3x minus 6 is equal to 0, that is 3x is equal to 6 or x is equal to 2. It is a vertical line which divides the plane in the left and right half planes, as you can see over here. As we have seen before, for inequalities 3x minus 6 greater than or equal to 0, the line is also included in the solution region. So representing it as a dark line in the solution region. So always do that. You represent here it as a dark line, not as a dotted line. In order to identify the solution region, take a point 0, 0 and substitute in the equation 3x minus 6 greater than 0 or greater than or equal to 0 and check whether it is satisfying or not. So when you do that, you get 3 into 0 minus 6 greater than or equal to 0 or minus 6 greater than or equal to 0, which is completely a false statement. So you can see the point 0, 0 is in the left half region and it does not satisfy the given equation. So the right half region is our solution region, which includes the line also. Now to solve y less than 2 graphically, I just have to take a line that is y is equal to 2, and then when I look at the inequality, I have y less than 2. Putting the origin, that is 0, 0 on this, I get 0 less than 2, which is a true statement. So now my job is to draw the graph for this particular inequality. So you can see that y is equal to 2 will be a horizontal line which passes through the point here, that is 0, 2. Since our inequality is less than, we don't have a greater than or less, greater than or equal to or less than or equal to, we just have a less than. So what you have to do is, we have to put a dotted line, and that dotted line you can see over here. And since the 0, 0 is satisfying this particular inequality, what you have to do, you just have to draw the shaded region in the downward direction or on the lower half of this particular line. Understood? So that is how we draw the graph for y is equal to 2. The solution region, nothing but the lower half plane. Understood? So far we have discussed about how to find solution for linear inequalities in two variables with the concept of half planes. Now tell me, if two or more linear inequalities are considered together, is it possible to find the solution graphically? We will definitely find about that in the upcoming videos. Now let's have a quick recap of what all we have learned.
Manorama Horizon, learning made simple.